first of all, hello everyone, and the ones who are joining right now. Today we have Peter from XPLUS. First, a small word about XPLUS. It's a strong partner of AGS in all IT architectural matters. Um, Currently, we're carrying out the architect development program that we've developed with them. And if you have questions, you can contact Segolen Branchen or from AGS Academy or Benedict Benoit. Oh, he's here. Um, Around this architect development program. Peter here from XPLUS is a partner in XPLUS in an IT architecture consultancy firm with offices in the Benelux and in France. He is specialized in designing digital transformation at large and modern applications architecture foundations like microservices and event-driven architecture in particular. Peter has more than 25 years of experience in IT, of which more than 20 just in architecture. He's a guest lecturer also at Antwerp Management School and has provided guest lectures for a decade at Solvay Brussels Schools of Economics and Management before. So without further ado, Peter, I think you're the best person to introduce also the subject. So I'll leave the floor to you.
Okay, thank you,
Okay.
Christopher. I'm going to share my presentation. I assume that is the intention. So today we're going to talk about composable applications, modular architecture. By the way, Christopher, thank you for the introduction. So I don't have to introduce myself anymore, which is always a little bit awkward. So we're going to talk about composable applications in a modular architecture. That was the request of Agrias, of Benedict, and yourself. And if I took a slide which you don't have, but which I added this morning, is sort of okay. What was your expectations about? I'm reading here one of the paragraphs. One of the most effective ways for organizations to drive agility and meet these rapidly rising expectations of the business is through becoming a composable business built on reusable APIs. These APIs can be used in turn to turn the organization's digital capabilities and data into a series of interchangeable building blocks that employees can reuse in other ways to build their own solutions. Per Gartner, the composable business means creating an organization made from interchangeable building blocks. Now, um, this is of course something that today a lot of companies are trying to do, and so that's what we're going to focus on. What we will have to do is sort of translate this kind of general statements into something that is more practical and implementable. Um, and as you requested at the bottom is focus a little bit more on the technical aspects without forgetting the whole business aspects. So as I'm an architect, this presentation will be mostly around a architectural approach. I've tried to make the presentation kind of complete in the sense of, okay, a logical whole. Some aspects will be more emphasized than others, so we will see at the end whether I achieved in my goal. So I would like to start with this slide, and this is sort of the most business slide I have to say for the presentation. It's about the business who, like always, wants to move faster in providing new offerings to its customers, but in a modern context. And the modern context, we all know that. That's about people want to be more mobile, want to have more self-service, they want to be more empowered, and we want to be able to provide new functionalities to those customers through these channels. Now, what we see the last number of years is that we often use a concept of customer journeys, where we're going to take a customer who says, oh, I have a certain need, or I get up in the morning and I need to do something. And then you try to guide him through a path of, in the end, having also involved one of your own products. And you want to see, okay, how would that look like? And then under that, what you're trying to do is, okay, how do we provide it then in the most frictionless manner in the current situation with mobile and all these things? And so you try to orchestrate your customer journey. And in order to implement them, you need applications. But for one customer journey, you need these 5. But for another customer journey, you need another 6. But they reuse some of these 5 that you had before. And so the goal is to be able to construct new customer journeys for obviously for your customers, but composing of existing applications and then some new that you build, and then by sort of orchestrating them. So that's kind of the high level idea of what we mean with composable applications in or the way how I translate it, the composable applications in a modular architecture environment. So from here, we will move forward to like, okay, how would that look like today? What do you need today in order to do that? Now, what is important is to understand is that the whole idea of composable applications is sort of the holy grail of IT, and then of course IT and the business that they serve. Why? Well, it fosters reuse of business functions, which is always good reuse, which these business functions are expressed in code through a modular architecture. That means it's separated from each other, and these well-defined functions are separated from each other, as I said, but they also can call each other and connect to each other if they need to through standardized reusable interfaces. That's kind of, in a nutshell, what we want to achieve. Now, on the other hand, this is not new at all. I mean, this has always been a goal of IT, um, and actually almost since not the beginning, but since a very, very, very long time. I mean, I've seen several mainframe implementations of different customers, and I've seen that composable applications already exists on the mainframe. There is this technology on the mainframe, and not everybody uses it, but a lot of customers use it. It's called the IMS Transaction Manager, and which already on a technological level forces applications to be sort of granular in a similar way, which means like you cannot put everything in there. So you're going to focus what you put in an application. So they all have a similar functional scope and a similar performance characteristics. And then they have a lot of these applications on the mainframe. But when you come to the mainframe from the outside world, you come to the mainframe through some sort of service entry point, which is just another application that exposes an interface with a certain protocol, and which then coordinates then the other applications that you have on the mainframe. And they also use sort of a standardized interface, which is called COBOL copybooks. Well, you can discuss about how standardized that is, but it is a kind of standard. And through that combination of sort of a certain contextual applications that are wired together by these service entry points using a COBOL copybooks, you can already achieve in a way, a modular architecture and composable applications. Doesn't mean that everybody does it, but I would argue that it is not something that is new. Of course, with regards to the mainframe, yeah, that is limited to the vertical scalability of the mainframe. And okay, and this is sort of controversial maybe. It's not future proof in a sense that what you see is that today, and I see that in different customers, the mainframe is there mostly for the core business logic that already exists, and most of the new stuff doesn't happen anymore on the mainframe. There's also the question of, okay, where's IBM going in the end, and so on and so on. And that's not the purpose of this presentation. This slide is merely there to say that composable applications in a modular architecture is not something that we just started doing. Actually, 15 years ago, we had already service-oriented architecture. At that moment, there were already a lot of distributed applications which were really monolithical. They had their own graphical interface, they had their own business logic, they had their own data, and there was a lot of business logic in there, a lot of business functions. But then they needed data from elsewhere, so you started to integrating, and then there was the idea, yeah, but can we do that more in a way that's more composable and that's more modular? And what happened is that they started exposing their functionalities through what's called web services. That was a standard, but it was relatively difficult to make or very verbose to do, but it was a standard interface. And then in order to connect these applications with each other, which don't necessarily in a sort of flexible way, like if I change an application, I don't want to change all my integrations, they put an enterprise service bus in there, which accepted the calls from the applications through that standardized interface, and then routed it and potentially changed it to another application that was the target. Yeah. So in a way, this was a lot of companies still have enterprise service buses, but that was kind of the way to create composable applications in a modular architecture, like yeah, 15 years ago up to, let's say, 7, 8 years ago. Now, one of the things here is that this type of ideas were really made, came out of a corporate context and were mostly supported through middleware vendors who also made a lot of tooling for it. So they had an interest in having things that are relatively complex, which then turned into like more sales for them. That's again maybe a controversial statement, but it's what I saw. If you look at the IBMs, the Oracle, the software IJs, you had huge stacks of tools that you had to buy in order to assemble this. That doesn't mean that today it's going to be much better, but there it was a mostly commercial venture, I would argue. Now, what happened in the meantime? And in the meantime, the main thing that happened was that the cloud happened and mobile. Now, of course, this is not new. This is something that's going on for a number of most of a decade, if not more, actually more of a decade. But what we see is that the rise of these internet giants, the Googles, the Amazons, the Facebooks, the Apples, the Microsofts, you can also say, at least in the cloud environment, in order to serve their needs, they needed more than just what these commercial companies offered as tooling. And they had such a scale and such huge data needs that they gave a new way of developing applications and handling data at really internet scales. Sorry, is anybody a question? Or somebody's not on mute? So in order to do that, they developed themselves internally a lot of tooling that in the end, most of the time, they open sourced. They say, hey, look, guys, we made this. This was useful for us. Do you want some? And we will look at these things. And this open source tooling in the beginning, it was like, okay, why would you want to use that? Well, you want to because we're not internet giants. No, but the principles that were behind these tools in order to solve that type of problems, they're also useful for us companies of a smaller size, because in the end, more and more of our business becomes really digital, needs to move towards the outside world, to our customers through mobile with self-service. And we are going to have a lot more signals and data first coming in with all these increased number of interactions, but also we need to have more data in order to make better decisions. And we want to be able to capture that. And then that tooling that is there and the principles behind there for developing applications is actually also usable for us, even if we are not going to have that massive scale. Yeah. So so that is basically the main difference. And so if you look at the evolution, and I'm not going to go through all these elements in the slides, but I think this is a nice euphemism of how or analogy of how you can imagine it, is that we went from big monolithic environments over pizza slices of applications, which you had to take several bites of, into these small building blocks, small pizzas, how do you call that, for that you eat at receptions with a single bite. So you're going from a highly cohesive environments to environments that are much more flexible and scalable. There's also obviously some disadvantages there or challenges there and constraints there, but that is where we move to. And this is literally a multi-decade evolution. So everything that you see is not necessarily a revolution like we see with the cloud and the internet scale stuff. That is more of a revolution, but the way applications evolve to achieve the business needs is this long-term evolution, and that's basically driven by those needs towards more fine-grained building blocks, multidisciplinary teams where we can develop them in our own isolation, where we can also deploy them individually, so we are less dependent on others, and with a focus not just on internal anymore, but also on the external world. Yeah. And the rest of the presentation, we're going to focus obviously on the microservice part. So a complete new stack a new technology stack for creating and running applications arose. uh, um, where you start obviously from the big driver, which is mobile, where we now want to interact with all our customers in a much more intimate fashion from a remote digitally, in a digital way and with self-service, where we need to open our internal functionality also to these customers, but also to third parties. And that's something that we do through APIs, where we need to be able to cope with the much higher usage of IT systems, because now suddenly all our customers become also, and partners become users of our IT systems, and they use it not once every month, but every day, basically. So we need to have a need for much more scalable application architecture, but also a much more modular architectures, so that we can bring new functionalities faster to the market. And that has become what we call a microservice architecture. And then in order to be able to react much faster to changes and the increased data in our managing the data in our environment, or at least moving that data in our environment, we need to be able to emit state changes and capture them elsewhere where we need them, so we can actually react on state changes and don't need necessarily to wait until somebody does something. And the volume of data that we have, we want to analyze, we want to make better decisions, we want to be giving a next best offer, real-time next best offer things, we want to re-operationalize our data more. So we have to have ways of capturing that. That used to be called big data. Now we put that in data lakes or data hubs, or what you want to call it. And to enable all this, we need to be able to develop in a much more industrialized way, using what we call a DevOps environment with continuous integration and continuous deployment. And all of this runs more and more into a cloud environment, which is simply somebody else's computer, but presented to us in a way which makes it also much easier for us to manage our environments through self-service, rather than that we need to ask IT to do something in a very manual basis. Now, all this is a whole chunk. It's too big for this session, so I will focus on API management, microservice architecture, and event-driven architecture here. So the rest of the presentation, we're going to zoom a bit in there, and then we bring everything back together in a kind of reference architecture and environment. And of course, the focus here is also, like always, the question remains, how does this support composable applications? Okay. I'll just continue. If there's any question in the meantime, you can ask, but I will try to continue because we have still some material to go through. I hope this is sort of your expectation.
Yeah, it's perfect. And Peter, Cristobal and myself, we are following the chat. So if there is any question, and please, if you want to raise question, use the chat for. And although Cristobal or myself, we will then liaise with you, Peter.
Okay, good. Thank you. Um, I'm going to start with microservices. Why? Because it's there where it starts. If you look on the left, you have a monolithic application. It's a car rental application, and all the functions are literally developed in a single package. It's deployed in a single package, and the whole data model of each of the functions is also brought together in a single data model. And the problem with that is, the good thing with that is that everything is close together. It's very um, performant in that way. But if you want to change stuff, your package becomes always bigger and bigger and complexer and complexer. And over time, you see a kind of diminishing returns to scale, let's say, and it becomes more and more complex over time to deploy. What you do on the right side, you see microservices, a bunch of microservices where each microservices takes responsibility for a particular business function. In this case, one is billing, another is passenger management, another is driver management, another one is payments. They have their own data store. And within this functionality, where they manage both the business logic and the data, which is called a bounded functional context, they can basically independently evolve. If there's things that you want to do around passenger management, well, you're going to evolve that component. If there's things that you want to do around billing, you're going to evolve that component. And they talk with each other over standard interfaces, which we call APIs, and which we will look at after. So the big difference is that in the monolithic application, as apart from the fact that it's a big one big chunk on which you have to work with a big team probably, is that everything is communicating with each other in memory, whereas in microservices what you're going to have is that they are communicating with each other over the network. So they're more separated from each other. But another thing that's different is that you can work with different teams, each responsible for their own functional component. So microservices is something that's really supportive to what we call an agile environment. So most companies these days have moved already through an agile environment where they work with small squads working independently on backlogs of work. And if you are safe, if you use the safe framework, then you have release trains, so continuous releases of certain aspects. And then you just add work over regular periods of time in your backlog that you then process and then you just ship through and deploy. And the problem here in classical IT environments is that most monolithic IT assets are too big to be just managed by a single squad. Or there's too many functions in there. There's too many initiatives asking something to change of it with incompatible timelines. And so it creates inefficiencies and overhead. Whereas microservices, through their as these building blocks, with which you compose your own applications, they are perfectly suited for single squads, and squads can even manage multiple microservices. So it's much easier to evolve these without having to take into account all these other functions that also may have to evolve. And so one of the dynamics is that if you have monolithic applications, is that over time you're going to split them up into chunks that are manageable by these individual squads and become microservices. This is not even, I would say, extremely new. I've seen that happening when people go from big three-tier web applications towards newer redevelopments. They're typically smaller. And so this is basically Conway's law that is happening. And Conway's law posits that your application landscapes starts looking like your organization over time. But because if you develop in small teams, yeah, well, then these small teams are going to make small stuff. They're not going to make huge stuff because they cannot manage that. And so if you have huge stuff and you have then different teams working on it and they're in each other's way, they're going to start breaking these things up into smaller stuff that they can manage. So basically the organization is sort of conducive for driving your application landscape. And so if you want to go towards a more composable applications with a modular architecture, then you basically are forced to go into split up your monolith assets and forced to go into agile and towards microservices. Okay. And this is then an important aspect is then, okay, that's nice that you say make functional business blocks, but how do you redefine these? There's always this discussion about what's the right granularity, what belongs in there, what doesn't belong in there. And so here we propose something like domain-driven design as a kind of a framework to help you identify the right business functions. And so the idea about domain-driven design is that your business exists in a number of big domains, and we're going to connect the implementation of our software, of our applications to these domains. And you start from your domain context as a business to give meaning to concept and terms. There's always a discussion, what is a customer? What belongs to a customer? What is not to a customer? But a customer depends on the context that you're in. When you're in sales, a customer means something different and has different attributes than a customer in a fulfillment domain when you're actually going to deliver something to the customer. And they might have a different view on that. And so the idea there is to allow these differences to exist, but where each domain takes responsibility for the meaning of their own concepts. So other tools, and so in order then to make it more sharp what is in a domain and what's not in a domain, you can use a number of things that we use, frameworks and work products that we often use in architecture in order to make that more sharp and to create boundaries. One is the business capability map. A very important one is a business glossary that helps you define these contexts in their domain, and also enterprise data models. Now, these enterprise data models, they're more like high-level data models. They're not necessarily they're not canonical in the sense that there's only one customer object. There may be different domains data models in there. The problem with canonical data models is just that you cannot define a single customer in a stable, a single term like customer in a stable way. So you have to allow each domain to have their own context. But all these things help you when you create an application as a composable application, where you say, I'm just going to put a certain functionality in a single application through a microservice. How do I do it? Well, this is a way how you can make that clear what your bounded context is. Now, that doesn't mean that this is purely top-down, where you first need to have all these things. People within their domains have a lot of domain knowledge. They know also quite some of what belongs together, what does not belong together. So you can perfectly marry that with a meet in the middle approach, where partially it's bottom up and but also top down. Okay.
Sorry,
So
Peter,
yes.
before we move on, we have a question here in the chat from Mark Lebo. In such model with multiple data repositories, each dedicated to a bounded context, how can
Mhm.
we address cross-company reporting? How can we ensure data consistency?
That's a good point. And we come to that partially when we talk about event-driven architectures. But the thing is that you manage, I mean, somebody needs to be master of data, right? And this is where the master of the data is. That doesn't mean that you cannot use other data, or you cannot give that data away to central repositories, let's say for reporting and stuff like that, right? This is more like, okay, I want to have a modular architecture with composable applications that I can mix and match in new customer journeys. Then this is sort of the way you go. Now, if you then need to be able to share that data, then we will see in the rest of the presentation how that is done. And that sharing can be like, oh, another application needs something from you, or, oh no, I need to give also my data in order to do, let's say, cross-company reporting away to a central entity. So all that stuff we will touch upon in the rest of the presentation. So I would say hold that thought. Okay.
Thank you, Peter. Also, we have another question, or do you prefer that we have a Q&A session at the end, or do you mind that we interrupt you with these questions right now?
Um, I would say let's paste it in both. I don't want it to be just a lecture. I'm okay with answering a couple of questions, but let's limit them per section by one or two, so that we can kind of move on and I don't run out of time at the end also.
Okay, so if you don't mind this second question, and then
Yes.
we let you continue with the presentation. So we have here a question from Frank saying that he has built applications from the ground up using monolith and microservice architecture, that he thinks that monolith will work best with small to medium enterprises with 5 or 10 developers. But what would be the size of a company that microservices start to make sense?
I would disagree with the original premise in that I think that more and more there is support, especially by the cloud providers, where you now don't have to manage huge infrastructures yourself, where you have those sort of at your disposal, that even small companies can use the microservice concept. That's my position. Of course, we will see what type of infrastructures are needed in order to manage this. There is stuff to manage there, and if you have to do all of that yourself, then yes, you might be right that given the overhead in the management, you need to have a sufficient large IT team, which you might not find in small to medium enterprises. But I think that problem has gone away already 1 or 2 years, a couple of years ago, I would say. So I disagree with the premise in itself. And I think there's a lot of discussion. You can go back and forth there. But this is my answer. Okay.
Thank you, Peter.
So we talked about functionally, okay, what's the bounded context, what we put in there. But once you start looking at a modular application landscape, there's also another non-functional part that comes into play. That is a concept of layering. Of course, you can have okay. Yes, I'm
Indeed. Yes.
sharing.
Perfect. Yes. Okay.
So I'll
Back in business,
back in
please.
business. So you not just have the functional decomposition in microservices, you're also going to start to think about, yeah, but what's the non-functional task it has? So like the entity ones, they manage data, the task microservices manage business logic, and then you have several business logic ones, but then you need something from this one and you need something from that one, and you don't want to do two calls. I mean, these discussions going to start happening, and then you're going to put an aggregation microservices in between. And even you might have an orchestration microservice to orchestrate several other microservices in between and so on. And ultimately, for your mobiles, you don't want them to connect directly to your, for presentation reasons, optimization reasons, you don't want them to connect them directly to the task microservices or the aggregation microservices, but you're going to have a facade microservice. Now, all these type of things becomes concerns in your architecture. There's also performance concerns there that are important, but it's kind of a world of how do you want to structure your applications in order to achieve the balance between, on the one hand, functional composability, but on the other hand, a number of non-functional requirements of considerations like, okay, I don't want to do too many calls out, or I don't want to put too much mixed business logic and non-business logic, and all these type of things. So these are concerns that you will need to think about. Now, okay, we have these microservices, we have the ideas of how to decompose them, but how do we deploy them? Because there's now small chunks of code, and I want still to be able to manage them. And for that, the concept of containers enters. This is where we start start really going into the technical part, because that's also a reason why a number of the innovations and we have seen over the last couple of 5-6 years that we move towards this direction. So with containers, what you do is you're not going to put everything into a virtual machine, which is huge because you have a whole operating system in there. And then typically you put one application in there, which is wasteful. You're now going to say, well, given that I just have a small set of functionalities, I also don't have that many requirements, and I'm going to combine all these requirements that my application has together in a single, what we call a container. And I'm going to deploy these containers somewhere individually. And I can have a container is pretty small because it just is your microservice. It's a couple of tens of megabytes maximum. And so you can have much more containers running on a system, then you can have virtual machines on a system. So you have many more microservices that you can run on an individual system. And that's also necessary because your big monolithic application is now become 10 microservices maybe. And so that's the way we deploy these things today. But then the question is, now I have a whole bunch of these containers that are running on a number of systems. How do I manage that? Because they also have to be high available. I need to have multiple instances running on this, and so on and so on. And for that, there is the concept of orchestrators came into play. So containers are deployed and managed by what we call orchestrator, and they manage the life cycle of a container. They're going to look at the container and say, are you in the state that you have to be? And if so, we stay. And if not, I'm going to scale you and I'm going to redeploy you somewhere else. Randomly in the systems that I control, so you are back in the right health that you should be. And it can be 1, 2, 3, 4 times, depending on the number of instances that you want to run. And it also provides a whole other set of infrastructural things, like I'm going to isolate you on your own network. We're going to make sure that the traffic gets routed through you by sort of load balancing, small micro load balancers that we call. Really, I'm gonna have it. So you see my screen? Yes.
Yes.
So,
Yes.
okay. So the way we do that is through what we call a service mesh. A service mesh is a little piece of is a piece of infrastructure where together with the microservice you're going to deploy a sidecar microservice through which all the traffic is going to go. And by being able to do that, you're separating infrastructure functions from business functions. So it's actually easier this way to develop your applications because you only need to focus on the business functions, and all the infrastructure concerns like logging, monitoring, security are managed by the sidecar application, which is controlled by the service mesh. And so the service mesh also ensures discoverability, because what it's going to say is, oh, this microservice runs actually on this system. And so if you want to connect to it as another application, then this is where you need to do it. And so that combination of technologies gives us a first embryonal composable applications platform. You have a container orchestrator with containers in which run microservices and which are bound together through a service mesh. And together they help you also with a number of transversal concerns like security, monitoring, logging, and observability. For these aspects, you will have additional tools probably, but these things can then interact with that basic platform. So now we have microservices as this enabler for composable applications. Now, well, for creating a modular architecture, but now it's more the question like, okay, but how do we now ensure composability by being able to interact with them? And for that, we want to turn our attention to APIs. Like we mentioned in the beginning, APIs are a very important part. Now, what are they? APIs are just contracts, and they are interfaces. It's what is visible to the consumer of an application, and it hides away the complexity of the implementation. The microservice itself will implement the API, and the API is something that it exposes to the outside world to manipulate the data. And so the data objects that the application manages should only be managed by the application. So no more integrations at the database level. All external manipulation of data should go through these APIs. And the thing is that these APIs, these interfaces, are basically web enabled. So you can just access them like any URL. Now, in the creating of APIs, of those interfaces, you don't just do that based on an individual request of an individual team that says, I need this from you, and you create a technical interface to exchange the data. You need to think as APIs with a business perspective. It's like a product that you develop, where you're going to say, look, somebody wants something from me, like my application is like a store. What are the products that I deliver, and how do I give it to them? So you need to think about what's the structure of an API, also in the context of domain-driven design, like, okay, what can I expose? What will somebody else expose? So there is no overlap in data, for example, or in functionality that I enable this way. So you're gonna try to do something like product management around an API. You're gonna think about how it looks like, and they have to be structured explicitly for that reusability. Now, there are APIs, most APIs are internally exposed because you just want your applications to communicate with each other. But when you expose them externally, you have to think additionally. You don't necessarily want to expose your internal structure. You want to expose something that's like a website. Your API becomes like a website, and it's a brand. So you're going to try to put branding aspects into that. Like, how do I want somebody from the outside world to interact with me? So as I said, an API is kind of like a URL, like you just any web browser uses, and it consists of a number of elements. And how you're gonna make these elements look like, that is again where you can use the same things that you use in domain-driven design to decide what the granularities of your microservice. You can use the same things to construct your API URL. I'm not going to go in all the details, but this is basically what an API is. of course, attached to that, you have definitions, which we will not go into, which allow you to connect the definition to your actual implementation. And there's a way then to implement that and to expose that physically. But this is what you have to think about when we say APIs as a product. You need to think about how am I constructing it so that they are nicely separated from each other, they don't overlap each other, but also they are kind of, when I look at it, I can see what they are doing. So typically you start with defining your API before you start with the implementation. So a contract first approach. And obviously you're also going to version them in order to ensure that you can evolve so that some applications still use the old version for a while the new version is already available for new applications. And again, just like in microservices, you're going to think about, okay, but this API has a functional aspect, but there is also a non-functional aspect. What am I doing? What am I exposing here? Am I exposing entities? Am I exposing business logic? Am I exposing process logic? Am I exposing facade logic, so front-end data? And again, there you're going to see that there are needs to say like, okay, in that case, I want it to look that way maybe, and in that case, I want it to look in another way. So this layering approach is also a connotation of reusability, like entity APIs. You're probably going to reuse much more than facade APIs, which may be made just for a single screen for your mobile app. So also these kind of considerations enter into the design of APIs. Now, I know this is all going a little bit technical and all that, but I want you to understand what the entire scope is of things that you need to think about when we talk about composable applications in a modular architecture. That's not just words. There are real implementation and design aspects behind it that go behind it. Now, what is very important for APIs is that they require governance, because typically that's what API as a product is about. It's like you're not going to make copies of product or things that overlap too much. So for integrations in the past, what you saw a lot is that there were a lot of integrations that sort of did the same, but they were made à la tête du client. Yeah, and that is not very good. That is not. Are you all hearing me? I just want to verify.
Yes, we can hear you.
Okay. So what you typically gonna have is, because APIs is the way that you are going to compose all your applications, is that you want to have a kind of a central governance where you're gonna see like, okay, this API, is that not too much the same as another? Isn't there already an existing API that you could reuse? So you're gonna create a central governance around in order to manage this, and also provide a central repository to reuse your APIs. And here in the example, there is a repository that also knows which APIs have dependencies on other APIs that you can visualize. So when you have a composable application, then that is because I want to combine multiple applications to create a bigger application, but I also want to reuse it, and the reusability is through the reusability of the APIs. So that's a key element. Now I have my applications, so I have my microservices, and effectively, like I said before, all these microservices are fronted with APIs. If I'm external to the company, I will not go directly to these applications. I will go through what we call an API gateway, and there you're going to probably change your API format to something that's more commercial and doesn't expose your internal structure. Yeah. And then when a microservice needs other data from another microservice, then it's going to connect to that other microservice using an API. And how does it know where it is? Well, that's thanks to the service mesh. So applications, you wire them together through API connections. Now, how can we then compose these different applications and structure them together that they are actually seen as a new application or a customer journey? If I want to make a customer journey which uses a number of these microservices, and I have another customer journey and they use other microservices and some are the same, so how do I keep hold of the whole flow of these customer journeys? Well, there's several ways you can achieve that. The simplest way is just that you're in the single page application, for example, that runs in your browser, today, these are like whole applications in JavaScript that you just ingest in the browser and you just manage it from the browser. So all the flow of your application, of your composable application is through the browser. And that's what you often see today. Now, in some cases, you say, well, I do not want that because it's like a complex process and part of the process is internal and that has to be managed differently. And I don't want to do that from the browser. I don't want to expose it in the browser. Then you're going to have a microservice that's having a workflow, an orchestration flow. So it's centrally, the front-end application will contact the orchestration microservice, and that one will handle all the interactions and drive the flow forward for you. But you could also do it differently. It's like, well, I don't want a central orchestration, and I do want it maybe from the browser. I just want to connect to it. But it's one microservice that will call another microservice that will call a third by itself. And in the end, it's like as if there is a virtual workflow that is managed, and that's called a choreography. It's just by virtue of one application calling another that you come to an outcome that you desire, but you still want to monitor that. So you're going to have these applications also send messages to a central choreographer that will say, oh, now it's in this application, now it's in that application. That gives you a way to monitor at least the intended flow. You could have a case management microservice where you say, okay, in order to be finished the whole flow, well, there is no flow, but a number of activities I want to monitor, or I'm going to accept calls, and then I'm going to manage those individual activities. And when all of the activities are done, then we will consider the case to be closed. Yeah? And there's a couple of others. I'm not going in detail for the sake of time that you can use, but there are many ways how you can then create these bigger customer journeys, let's call them, from all these individual composable applications and in a way structure them and make sure that the flow, that the intended flow is followed. So the important message here is that today you don't need like monolith orchestrators, big process components like you used to have in a service-oriented architecture. There are like much more lightweight orchestration engines that you can embed in a microservice, and that's also what you see being used. And it's also a way how you can create much faster or in a much more individual or independent way your own orchestrations reusing those composed applications. I would like to point back here to one of your earlier presentations that you had around, around low code and no code that you had. Actually, low code and no code application environments are really great consumers of composable applications as implemented by microservices. So what you have in the low code, no code applications is that the GUI and the control logic is provided by yourself. Like you're now become a developer yourself, but the environment that you use is easy for you to use. It's point and click stuff where you control the flow of what is happening. But then you need to connect to applications that provide you the actual functionality. And for that, all these applications are typically able to connect to APIs, to standard building blocks that are liberated by APIs. And so you can access functions that used to be only accessed by big monolith applications. You can now do that with your own small power apps or power automates that you could use. Yeah. So so this is also a way where you could say, well, the top end of my composable applications, the front ends and the control logic, I don't need to do that anymore explicitly myself as IT for the business, but the business can access a lot of these functions themselves through their own citizen developers. Okay, and that way you can create you can multiply the number of applications on the same logic that's encapsulated by microservices that way. Okay. So we come to a kind of an update of our composable application platform where we now added APIs, an API gateway, we added composable application orchestration, and we have the different consumers like mobile and web, like we always had. We now also have third parties, and we have low code and no code environments. Okay, so now I want to go, this is not, the subtitle here is not right. Now I want to go to a last part, and that is that not all applications require synchronous interactions. So when you use APIs, and of course, there are ways to use APIs differently, but when you use APIs, typically it is transactional. I mean transactional as in request reply. You're going to ask something explicitly to a microservice through an API, and the microservice will answer you. Now, you can also, sometimes you have a need for asynchronous interactions between microservices. And there is a concept called event-driven architecture, where you have these asynchronous event-based interactions. And what you have is, it's actually very simple. You have an application, a microservice that basically sends a message to a broker. And then there's another application that sort of reads that event and processes it. Now, this looks very much like the classic message-based interactions, asynchronous interactions, message queuing and all these type of things. But this goes further. In the context of composable applications, there are two main ideas. That is, first of all, is that applications don't store their state changes in a local database anymore. Not just. So yes, I'm a microservice, I'm a composable application, I have an API and I have my own data store, and every state change that I have, I'm going to store that in my data store because I'm responsible for it. But I'm also going to publish it. I'm going to publish it on a central broker. And actually, I'm not going to care about who consumes it. Yeah, it's there for whoever needs to have it. And the second one is that applications become what we call reactive. That means that instead of being driven by an orchestrator one way or the other, they're just going to look at when there is an event coming in somewhere that is of interest, and then they're going to process that event. They're going to react on those events rather than process it. And the way this is implemented typically today is through a central event broker that's highly scalable. And it manages all these events, and here you see them, through what we call an append-only log, which means that it just not has the event itself, and once it consumes it gone, it keeps a history of events for being used. And that allows us to think about these event-driven architecture not as integration components, but as data sharing components. So this is not anymore about, oh, I have application A and B and they need to be integrated. No, it just means I have an application and it shares its data with whomever needs to have it. That has a number of implications. So you enable that way a number of what we call data intensive patterns. And so this goes back to the need like, hey, we're going to have a lot more data to process over time because we have a lot more customers accessing directly our systems and a lot more signals coming in. And a number of these patterns are important in these use cases. Like an important pattern there is what we call event streaming. What means is that, hey, events are generated and they are immediately processed in flight before they're actually consumed. Another one is event sourcing, which means like, hey, I have this list of events, historical list of events, which provide me state changes on an object over time. And I'm going to exploit that time aspect in whatever it is that I want to do. So I'm going to materialize a view based on a certain set of events in this history log, and not all of them. And you can create different materialized views depending on your needs. So you could literally go back in time and back and forward in time. And a third one is where you have systems that are transactional and where changes happen, but that are maybe not scalable. And that says, well, I want this data also to be available in a scalable way to systems, to other clients that want to read it. And I'm going basically to send all these state changes through my event-driven architecture to systems that are going to read them and put them at a disposition for read only. This is a pattern called CQRS that you see more and more happening in the environments. And with this different patterns, and there are others, in this asynchronous way of working with state changes as events, you can create novel modular application architecture. And here is one example that I want to give you, and sort of leave you with. It's kind of, and I've seen it actually in one of your earlier missions that I did for AGEAS, that you're separating your front ends from your back ends, for example. And with a composable reactive event-driven application landscape, here is an example how you can achieve that. So I have my front-end microservices like we've seen them before, maybe even with different layers. And I have backend microservices. And when something happens in these backend microservices, they're going to publish their events, their state changes with the event broker. So they're there to be used by others. And one way that you can use them, and this is an answer to one of the questions earlier, is that you're going to siphon them off into a data lake for consumption, for reporting, or for a reoperationalization, for example. But what also can happen is that in the front-end microservice, something happens, and you oh, let me continue. So another thing that can happen is that data, that state changes that happen in your backend microservices are then propagated through in decentralized caches. So they're ready for being read in a structure that is optimized for front-end applications, in a in-memory data grid, for example, or on other ways. So it's that data is now out of that state change, which is very recent, is now out of the backend application and is now in a centralized or a decentralized cache available for consumption by these front-end applications. And as most transactions are read-only, well, you can start reading them very efficiently from these caches. Now, when something has to change, so a customer does an action or an employee does an action in his front end, then it kicks off through an API, an orchestrator, which will send or receive events to backend applications to exercise on, to take activity on. Now, you could say, well, you can also send that to backend applications as APIs, so that would be another way of doing it. But you can as well do that through events in case it's about things that are more case management oriented and you don't necessarily require an immediate answer. You just need, when there is an answer, you need to be able to pick that up. So in this whole exercise example that I send you, I have different macro layers that I defined, and each of these macro layers could have its own micro layers itself, but where I have decoupled completely my front-end applications from my back-end applications. So I can actually change my front-end and add front-ends and add orchestrators and new customer journeys much easier without having to touch anything from my backend. So I can have a different speed of a bimodal model where I have a different speed of evolutions, for example. So with an EDA, you can get much more flexibility through decoupling than otherwise possible. So in the end, we come to a kind of a rounded out a composable application platform where we've added to everything before. We added the EDA broker and streaming components, and this would then become a kind of a reference architecture for composable applications in a modular architecture. And this is how you would do it today. To answer the person who said earlier, well, that's quite a lot, right? That's quite a lot. Is that something that smaller companies can do? Well, the reality is that they do, because they're not managing by themselves all these infrastructural components. They go to Amazon or Azure, or they use SaaS components like the broker Kafka. You can get that in a SaaS component. And so the only thing you need to do is, at best, is to manage the topics and the actual, you need to say, I need to deploy this and so on and so on. So you don't need to manage all this infrastructure yourself. Now, larger companies like an AGEAS, they have to make a decision to what extent they want to get involved in there or not. They can use cloud functionalities there. They can use also say, well, we still want to be able to structure, let's say, the broker, the way it's implemented to our own liking. We have needs there, and then you have to do it partially yourself. But you have options there going from infrastructure as a service, doing it yourself, through platform as a service, where most of the infrastructure is already managed for you and you need to do most of the configuration, to even software as a service, where you just can start using it at a very high level. And so with that, I sort of achieved, reached the end of my story. I would like to thank you for your patience if I haven't lost you. And I am happy to say that we are here to help you if you would want that. And I'm open for further questions.
Thank you, Peter. In the meantime, while we check for new questions and while people put new questions in the chat, I'm going to send the last poll here.
Mm-hmm.
So you are going to receive it in your screen right now. And while you answer that, I'm going to be looking for the questions that we had previously that we didn't ask. So we have two from Ricardo in Portugal. In terms of user journey orchestration, what kind of tooling do you suggest? Tool that allows simple and complex orchestration, choreography, and aggregations?
And the answer, the only right answer to that is it depends, right? So the concept of having a microservice with an embedded orchestration allows for flexibility. You don't have to choose, oh, we're going to use IBM WebSphere Process Server, or we're going to use another one, which is very monolithical, right? And then everybody has to use that because you paid tens of thousands or hundreds of thousands or even more euros, and you have a team that manages that. If I'm a development squad and I can use Camunda, for example, because it fits my purpose and it's an embeddable process engine, and there's others out there. I'm not endorsing anyone here, and I can just embed it in my code. Who's going to stop me? Why are you going to tell me that I cannot use that? That's the whole point of the agile composable part. Hey, I have a customer journey and we are able to orchestrate that in this way. We're going to do that. And it could also be like, it's not a customer journey. It's just a small orchestration, which we could also express in Java, but we don't want to do that. So some of these tools are more fully developed than others. And so it depends. Now, if you want to do a huge what you're not going to do is going to have huge processes. You're going to more like orchestrate different sections of processes, for example, because you want to keep also that modularity in your process part, right? But if you say, no, I want to have a huge end-to-end process order to cash, and it's managed by one central process with then a number of sub-processes and all that, well, then it might be that you need such advanced functionalities that might not be available in those embeddable process engines. And then you need to see, okay, where does it stop? Maybe you then need that big centralized thing anyway, and you're going to use that as part of your landscape. But that is again really context dependent. But the outgoing position should be there are a number of embeddable ones. Use the ones that suit you best. And of course, you can standardize, because you could say, like, we have a central center of excellence around these things, and we prefer that you use this one or these two, one in this context and the other one in that context. That's all possible scenarios.
Ricardo, does it reply your question?
More or less, I would say. So I'm speaking a bit about obviously technical orchestration, but also business orchestration, almost going to creating business
But 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 for
workflows.
but for technical orchestration, there are things there like which are already old, like Camel and these type of things on which even commercial ones are based. And for business orchestrations, you can use things like Camunda, but there is also others that you can use. So these are fully BPMN 2.0 compliant and all these type of things. So you have a choice. I'm not saying that there's dozens and dozens of them, but I can get like 5 or 6 different ones that you could evaluate. And I think as time goes by, there will and this becomes more and more a natural way of doing things. You will see more and more of these happening. You can even use SaaS ones that you connect to SaaS workflows that also exist. And the question is that a good idea to be dependent on that?
Yeah, we are looking at Microsoft tools like Azure Logic Apps with a combination of Azure Durable Functions, plus eventually with the events that you mentioned as well, the Azure Event Driven
That
tooling.
could be a stack that you use.
Yeah, but if you can share with us the list that you obviously I know that you are not selling any tool, okay, but the list that you will say that most of your clients use currently, so that we just can take a look, that will be helpful. Okay, obviously I'm just saying because in terms of orchestration, I do see that we can we always have the term of reusability. Okay, so creating small pieces of orchestration does make sense, but I do think that having those small orchestrations all together in a single place that everyone can go get and reuse if needed, I think that's at least that's the way I see it. But
Sure.
okay,
And
thank you
if
for your answer.
Okay, sure. And if you use like these, look at the no-code, low-code environments, there you have orchestrations in there, and they're all centralized sort of in that cloud-based low-code, no-code environment. And then the main question is if you start using that as your main orchestrators or something similar, like you mentioned, it's like, okay, what is then the distance between the orchestrator and the actual logic? Because if you're going to do that in Azure and then your logic is in the data center or in Amazon cloud, then you have to manage that distance also. So then one of the considerations becomes like, okay, do I need embeddable in microservices deployed with the rest of the code close by on the same Kubernetes cluster, or do I indeed going to do that in the cloud in Amazon and then have all the logic somewhere else? Or in Azure and have all the logic somewhere else. So yeah, I mean these are all considerations that you need to have, and depends on your priorities. Yeah, is going to be the driver there. Okay, other questions?
Thank you.
Ricardo, you had another one that we haven't answered yet, and is that if you see a transition from monolith to microservices, or is there an in-between approach where you can for example, approach at the top layer, but have the data model still shared amongst a few services?
Sure. I mean, that's what you see. Yeah? I mean, you're not going to just take your big monolith that has taken hundreds of tens of man years or even hundreds of man years and just like, oh, let's do that up. That's something that's taken a long-term approach. But one of the first things that you do is if your is that monolith is still evolvable, is to slap APIs on top of it. And that's the first step that you typically take. Another thing that you do is like, no, it can't evolve, but we can integrate with this. That is that you're going to put little microservices on before in front of it that integrate with the monolith according to the way that the monolith is able to integrate. And then those microservices are mainly exposing the API. So there's many ways where you can keep, I mean, just think about your mainframe, right? If let's say you only can go with MQ or EMS Connect to your mainframe, well, you're not going to put your web application on EMS Connect. You're going to put it a microservice in front that is able to do EMS Connect, and you're going to expose an API. That type of things. Okay.
Ricardo, does it reply to your question?
Yes, yes.
Perfect.
Thank you.
Also, we have another one, which as this seems overly complex. Is there tooling to have visual overview of what we deploy?
So yes, Ed, there are a lot of dashboarding tools that help you with that. I haven't gone into detail there, but you have things like Prometheus and so on and so on that, for example, help you in these type of things. You have also the logging, the Alex stack that you do use to log all the events, and then you put observability tools in front of that. But the point that you make is relevant and is absolutely pertinent, because what you're going to have, hey, you wanted composable applications in a modular architecture. So before, in a monolithic architecture, everything was basically in your Eclipse editor, and you saw all your project with all your different files and all your different projects and so on that compile in one too big package in your Eclipse editor. Now you're sort of going to have all these packages as separate deployable applications, and you're going to combine them and they're going to call each other, where that used to be all in memory. Now you're going to have that all over the network. So yes, these are like, you could say, disadvantages in performance, in complexity. And so there are strategies to what if something goes down? Does it fail everything? How do you monitor that? And that there are additional tools that help you with that. So yes, you create additional complexity that way, but that's the whole point around then making everything more industrialized. Also, these toolings helps you with that to become much more industrialized so that that complexity, you don't have to manage that manually, but there is more automation around it to manage.
Okay.
Is that an answer? Uh, is that an answer to the question?
Mark?
Yes, I still find it the level of complexity that I see here means that not many people will be able to just grab it. So,
So
my fear here is that from people that would have the skills to understand functional and business wise the goal, that we have such a technical complexity that basically they get lost.
but you have the technical complexity already in your environment. So with all respect, if you want to go to something that has no technical complexity, then I think those low code, no code environments will help you, and you can stay there. I mean, nobody says that you need to do this. You do this because you have a need around composability of applications and so on. So if don't have that need, or my environment is not big enough, or I don't want to, you don't also, as I said, you can today, a lot of that complexity is already hidden within the cloud tools that they provide. You don't have to manage everything in there. For a developer, typically, he just writes his normal Java code. He puts that in a CI/CD pipeline, and then it gets deployed as a container, and a lot of the complexity goes away. Give on the condition that some of those things, like sometimes you need to create these configuration files so the orchestrator knows where, how many times he has to deploy it and all these type of things. There is complexity there, but what you see is then companies that they develop a little layer themselves to hide that complexity on the integration between your CI/CD pipeline and then the runtime pipeline. So I'm not going to say, oh, there is no complexity. Yes, there is a lot of complexity in the explanation and in the underlying things. And in some interface cases, there is a level of complexity that you need to manage, but you typically manage that once and then you standardize on that for everybody else. What I'm saying is, like, if you today you want to do composable applications, and this is sort of the reference architecture that's behind it. And even if you go to something like low code, no code environments, very probably underlying that is exactly this what is running. You just don't see it. The disadvantage, I would argue, with low code, no code environment or environments that you don't have that complexity exposed is that they made choices. They made choices in how can I reduce the complexity, but that means that you're just going to reduce a certain set of flexibility in either use cases or in capabilities or in functionalities that are available to you. And that's up to you to evaluate how far you want to go. I'm
Thank
not
you.
I'm not selling this. I'm just giving you the let's say what I would argue is sort of the industry standard today around that, and then what are all the consequences of that and alternatives.
Thank you, Peter. Here we have Frank who would like to speak, but also we have another question in the chat. So I just suggest we try to let Frank speak, but also answer to Evan's question. And if we have more questions, please do send them. We will liaise with Peter, but unfortunately we are at the end of the presentation. So let's Frank speak, and then we'll try to answer your questions afterwards.
Yeah, I guess just from my experience, please don't embark on this journey if you're not confident in the concepts that has been discussed today. Please have a level of confidence before you embark in composing your monolith into microservices if you currently have a monolith. Would you agree, guys?
Yes. I mean, there's two aspects here. On the one hand, you see a kind of an undercurrent in evolution where over time you're not going to be able to avoid this. It's like it's inevitable, Mr. Anderson, in the Matrix. It's sort of, yeah, I mean, nobody sells SOA ESBs anymore, right? Nobody does that anymore. They're now all being repurposed as a kind of event driven, what have you, and so on and so on. right? And also the skills in the market are moving towards that. So in a way, there is that. Now, the extent to which you are going to embrace this and the speed and what have you, that's your choice. And so, yes, you need to have a kind of vision of where you want to be and to say like, and then this is the way that we want to do it. I agree with that. You're not doing this on a Sunday or on just a weekend. This is for your IT environment to embrace this. This is a transformation. This is not an evolution. This is a transformation. But that transformation can happen over time. Okay.
Thank you, Peter. Also, for those having to leave, you are free to do it right now. But I see that the two people asking questions are still in the call. So it's better if we reply to them right now. Also, they're going to get recorded so everyone can see the
I'm
answers
happy to do.
afterward. Perfect,
happy
Peter.
to do
Thank
so.
you. So the questions from Evan is here, well, I understand decoupling is key for the modular architecture, but how do we avoid the common pitfall by most organizations by creating a small monoliths instead of microservices? Is DDD the only answer?
No, I guess not. It's one that I put forward because most customers don't think about it, that I see at the beginning. So I want to immediately set their minds in a direction like, hey, you need to have a way to make your bounded contexts in a good way. And if you then say, yeah, but I need a kind of a framework in order to hang my coat on, I would say, then well, why not use that? And I don't even use DDD as in a very strict way. I use it in a very opportunistic way. It's mostly to say you need to have something where you cut up your functionalities in logical blocks so you don't get in trouble later with overlapping functionalities or functionalities that in the end are small monoliths. Like you said, you need to have a strategy there and you need to kind of have a way forward and a methodology that you sort of follow in order to do that. Do you have to do that to the letter? I would say no. That's where the top down, bottom up comes in. And that's also where architecture comes in.
Okay, Evan, does it reply to your question?
Yeah, it makes perfect sense because way back I understand people were keep harping on DDD, right? But I think the bounded context is key, but that's not the only answer. Thanks for that response.
You're welcome.
Perfect, thank you. And now the last one is from Benjamin. Do you need an overview of the whole landscape before moving to this kind of architecture, or do you think it's possible for each team to move individually?
Well, what you see is that most companies started with APIs, then they started doing microservices, and only now they're really started doing event-driven architecture. If you come from a pure application point of view, there are other companies that started with event-driven because they came more from a data perspective. What you see here is a kind of reference, culminating reference architecture. Um, um, and the answer to that is it depends. Where are your needs? If you have a need to end, how do you say it? If you have a need for both request reply as synchronous and asynchronous traffic, yeah, then you may be forced to look at both event-driven as APIs at the same moment. But you can also grow into it. Now, in that, hey, I have a monolith, I'm going to put an API on it. I'm just doing APIs, I'm just adopting my monolith. Then you say, well, now we want to use OpenShift or we want to go in the cloud where we can effectively just drop code and automatically it's going to run under the covers on something like a Kubernetes or even a cloud specific. I want to do that, but then you're going to immediately think like, how do I manage these applications? How do I wire them together? So you can depending on your needs, you take one approach or the other, and then you're going to augment it as you move along. I don't advocate for having everything at the same moment. I'm just thinking that as you start moving in that direction, that in a natural way, your needs into having more of these things available to you are going to arise. But you can definitely pace it.
Okay, Benjamin.
Yes, thank you. I was just wondering about the capabilities. If the team is moving individually, are you not afraid that at some time some capabilities are also moving from one team to another without a common agreement?
But It depends what team, what is the size of the team that you're talking about.
Yeah, that indeed it depends companies by
I mean,
companies.
if you're like a huge corporation where you have different teams and one does middleware and the other one does development and the other one does this, then the problem is not like, oh, when do we start with what? It's more like, oh, everybody is starting in its own corner with its own thing. How do you create a coherent architecture and not just a bunch of tools thrown together? And that's part of my presentation. I'm advocating like, look, make a reference architecture so you know that these things have to be able to integrate with each other, and that if one team goes one direction, that it is still, let's say, complementary to another team in its own corner with its own tools going in another direction. Now, what you also want to avoid is that you have 3 or 4 different tools doing the same. Now, again, if you're like a sprawling group like Ageas, maybe you don't want to standardize because you have skill sets or regional flavors that are more popular, but it still remained, you could still agree on a kind of a common reference architecture or on common interfaces and all these type of things. So of course, if you have a group context, then everything becomes a bit more complex to manage, and that's also maybe something where you say, well, everybody goes his own ways, and then but at least conform to the basics, let's say.
Okay, thank you.
You're welcome.
Okay, and that was the last question. Thank you very much. There are a lot of people that had to jump to other meetings or leave this one. But I really want to thank you, Peter, for the very insightful and qualitative presentation today. I'm sure that everyone has enjoyed the presentation today. A lot of questions, a lot of interactions. So thank you very much. It was unfortunate to have the problems with the internet connection,
I
but
apologize.
but don't worry because it's completely fine. With this qualitative presentation, you can have those problems if you want.
Yeah. Okay. Thank you very much. And I would say, like, look, if you guys want to look further into this or you need help into that, well, as you said, we're already helping Agias, and we're very happy to help you on these aspects too. And I hope we have convinced you that we can say something about the subject.
Of course. Thank you very much, Peter. Thank you,
You're
everyone.
welcome. Okay. Goodbye.
Bye bye.